All right, good day, everyone, and welcome to this year's hurricane briefing for 2020 after yet an active season last season. The material I'm going to cover today is basically I'm going to follow the same format as previous years because I think it's a good progression of information the way it's laid out. So I'm going to start by talking a little bit about the meteorology with these storms. And then we'll take a look at the 2019 hurricane season and spend a little bit more time on Hurricane Dorian, which was a significant event over many areas in the Caribbean and even up here in Canada, before looking ahead at 2020 at what we might expect. And then we'll finish off by looking at some information sources to monitor these types of storms. So why focus on tropical cyclones? Well, tropical cyclones have a significant potential to cause loss of life, and you just have to look back at the 20th century where more than 80,000 fatalities resulted from tropical storms and hurricanes in the Atlantic. They also create a tremendous amount of damage, and just since the year 2000 has resulted in more than, well, almost $800 billion US in damage as a result of hurricanes and tropical storms. Another reason is that they are different than the extratropical storms that we tend to see throughout the entire year. These storms really are concentrated over a very specific time of the year during the warmer months. So it's good to review these storms and what we might expect from them. So if we take a look at the storms that we get year-round, they're called extratropical storm systems. They form as a result of an imbalance in energy around the globe. So essentially, the sun warms the equator substantially more than the poles. So you end up with a fairly significant energy deficit at the poles compared to the equator. So a lot colder air is found up there compared to the equator and the tropics. So the way nature tries to counteract that imbalance is sending warm air northward and cold air southward. And the way that it's done that is through the formation of these extratropical storm systems. That balance is never actually achieved, but it's a continuous thing that happens over the course of the year, which obviously is way more frequent in the winter months because there's a larger contrast in temperature between northern latitudes and southern latitudes, at least in the northern hemisphere. So you can see to the right here the tracks of some of the stronger extratropical storm systems over the period of '89 to 2009. Now, so these extratropical storms are driven by that north-south temperature contrast. A lot different when we're talking about tropical cyclones. They also form as a result of an imbalance in energy, but rather than the imbalance being in the atmosphere, it's rather in the ocean, where the sun over the course of the summer months heats up the oceans. There's a tremendous amount of heat energy stored in the ocean, which has to be distributed somewhere. So hurricanes kind of regulate the ocean temperatures. And when the ocean temperatures get too warm, these hurricanes start to develop to redistribute some of that heat into the atmosphere. And the middle image here, you can see that these storms, if you look at that cross section, a lot of the air that flows into the storm flows upward very, very rapidly and flows out the top. Some of that air flows in towards the center and then descends towards the surface. Whenever you have that, you have the drying out of the air, and then you end up with the eye of a hurricane, which is in some of the stronger storms are clear right down to the ocean surface. And you can see how the tracks are different as well. So the tracks of tropical cyclones dating all the way back to 1851 are displayed on the right here. So you can see how these tracks are different from the tracks of the extratropical type storm. Now here in Canada, we're faced with something that's a little bit different. We often feel the effects of what we call a post-tropical storm. Now, post-tropical storm is a storm that actually started off as a tropical storm or a hurricane and transformed itself to something that looks more like an extratropical storm in terms of its structure. So if you look at the hazards, specifically wind and rain around a tropical storm, as you move towards the center of the storm from the periphery of the storm, as you move towards the center, you will encounter these bands of progressively stronger and stronger winds right up until just before you get to the center, where you'll encounter some of the strongest winds associated with the storm. Once you get into the center, the winds are lighter and sometimes dead calm right in the exact center. In terms of rainfall, the rainfall is distributed pretty evenly around the center of the storm in the pure tropical phase of the storm. Now, what happens when the storms come up into the more northern latitudes is it goes through a transition called extratropical transition. So it goes from the tropical type to the extratropical type, and the resulting storm is what we call a post-tropical storm. So we know that the speed of the storm, when this happens, the speed of the storm increases. And then there's a clear dissection usually between the wind and the rain, with the rainfall kind of shifting over to the left-hand side of the track, with the strongest winds being found on the right-hand side of the track and removed somewhat from the center of the storm compared to what you'd see in a pure tropical storm. So the speed of the storm increases, the rain shifts to the left, and the strongest winds are on the right. It doesn't mean that there couldn't be damaging winds on the left. It just means that the stronger winds found in the storm are usually going to be on the right-hand side of the track. So these are things that we know, and it helps us prepare for some of these impacts when these storms come our way. So we classify these storms by their maximum sustained wind speed. So when a storm the winds reach above 63 kilometers per hour, that's when the storm gets a name. When the winds reach in excess of 118 kilometers an hour, that's when it actually gets called a hurricane and it keeps the same name. If the winds exceed 178 kilometers per hour, that hurricane is referred to as a major hurricane. And you can see how these storms look different from space. This is actually one of the techniques that we have to try and determine the intensity of a storm is based on how they look with on our satellite imagery. There's a very well documented technique to try and estimate the intensity of a storm just from how they look on satellite. So looking at the climatology of tropical cyclones, the first few storms of the year that we see are typically in the western part of the Atlantic or the Gulf of Mexico, and this year is no different. So in June, that's where you typically see your first storms start to develop. Once you hit July, that shifts slightly somewhat towards the east. And then August is really when things start to pick up and you see a lot more storms develop, especially towards the end of August, with September being your peak month of hurricane season. And then especially the early part of October, we tend to see a lot of storms develop then as well. And then finally in the month of November, things start to quieten down a little. So that's kind of where we see these storms develop and at what times of the year. So September, again, is our peak month. However, there have been tropical cyclones in the Atlantic in every single month of the calendar year. So if we look at what happened last year, when we had our briefing towards this time last year, NOAA had just issued their outlook, which called for 9 to 15 named storms, 4 to 8 of those becoming hurricanes, and 2 to 4 of those hurricanes making it to major hurricane status. So you can see on the right here, the actual numbers for the season. You can see how it kind of fits into that range. NOAA issues this outlook at the end of May, and then they actually provide an update, one update in early August. So the August update, they bumped up their numbers a little bit. I think the higher end of that named storm range was somewhere, I think it was 17. So the predictions for last year were actually quite accurate. It worked out quite well. So we did have 3 major hurricanes, of course, Dorian, Umberto, and Lorenzo. So if we look at where these storms developed and where they went, this is a map of all the hurricanes and tropical storms from last year. You can see it's pretty much dispersed over the entire Atlantic. Only that area south of Cuba and Haiti, Dominican Republic, didn't have any storms go by there. But for the rest of the Atlantic Basin, there was another busy year, at least from a number of storms perspective. Here in Canada, we had actually 7 storms that entered our response zone. 4 of them just barely entered the response zone. 3 of them, the 3 that you see here, Erin, Dorian, and Umberto, are the ones that we actually issued bulletins and track forecasts for. So we'll kind of cycle through the season from last year, which got underway early, as the last 2 seasons have, with Andrea, which formed between Bahamas and Bermuda on May 20th. There were no major impacts there. So we had to wait just over a month to get our next storm, which was Barry, that formed on July 11th and eventually became our first hurricane of the 2019 season. That storm created significant rainfall and quite a bit of flooding along the Gulf Coast area. There were no fatalities, but there was about $600 million in damage there. And then we had Chantal that formed on August 20th, but again, no major impacts were reported with that storm. And then finally we had Dorian that formed in August, towards the latter part of August, but I'm gonna shelf Dorian for now because as Dorian was starting to get going, we had another storm, Erin, that developed within our Canadian Hurricane Center response zone. So we were expecting some strong winds, heavy rain over certain parts of the Maritimes, which we did end up getting. Some areas got in excess of 150 millimeters of rain. Parts of northern Nova Scotia, I think, maxed out at about 170 millimeters of rain. There were strong winds, power outages. That was on Thursday, August 29th. So on Friday the 30th, we were still kind of dealing with the aftermath of Erin when our focus quickly started to turn towards Dorian, which was still churning down in the Caribbean. So going back to Dorian and looking at its origins, while we saw this disturbance develop on the 24th of August, and over the course of the day, the winds continually increased. And by 5 p.m. that day, the estimated maximum sustained winds were estimated at 65 kilometers per hour, which means that at that point it was given a name. So Tropical Depression 5, so it was the 5th tropical depression of the year, was given a name, and it was given the name Dorian. So early on, looking at some of the predictions, this is the forecast map that the National Hurricane Center had. And within a few days, it was expected to move towards the Dominican Republic or somewhere around Puerto Rico. And then as a tropical storm, and it was unclear if Dorian would even survive the mountainous areas of those 2 islands. So it was kept as a tropical storm in terms of its forecast for the entire 5-day time period. And again, there was even questions as to whether it would even survive, even though this track shows it maintaining itself as a tropical storm for that 5-day period. However, on August 28th, things changed for sure. Basically, the track ever so slowly started to migrate a little bit further towards the east. Excuse me, to the point where it was no longer expected to make landfall in the Dominican Republic or even Puerto Rico. And it was expected to now go over the Virgin Islands or basically stay over the water in that area, which would have kept it a lot stronger as it moved into some warmer water north of those islands. And that's exactly what happened. That's where the storm ended up being. And given that now stronger storm moving over warmer water, at that point, the forecast was for the storm to become a major hurricane as it headed towards the northwest and eventually towards the Bahamas. So on Friday, August 30th, again, while we were dealing with the aftermath of Erin, Dorian was still forecast to make landfall in Florida. And the hurricane began to rapidly intensify at that stage, which is defined as 30-knot increase in wind speed in a 24-hour period. So about 60 kilometers per hour in about a 24-hour period. And as Dorian continued to rapidly intensify, it reached major hurricane status on Saturday the 31st. And it was right around that time that we started to see the first indication that rather than making landfall in Florida and possibly exiting into the Gulf of Mexico, we might be dealing with a storm that is making a sharper turn towards the north. At that particular time, there were preparations taking place mostly in central Florida. Orlando Airport shut down, as did Disney World. There wasn't anything shut down along in South Florida at that time, but they were getting ready to do that. There was some coastal evacuations that were underway, and it's on that Saturday that we began our initial discussions with our emergency managers here in Canada. So over the next day or so, rapid intensification continued, and by 9 a.m. on Sunday, September 1st, Dorian reached Category 5 status with winds of 278 kilometers per hour, peak winds of 361. You can see the difference here. Dorian now has a very well-defined eye compared to just the day before or a couple of days before. And the storm was headed towards the Bahamas. And as it was heading towards the Bahamas, it started slowing down, and unfortunately for the Bahamas, it ended up staying in place for about a 3-day period as a Category 4-5 hurricane. You can see this close-up satellite image of the storm as it's going over Grand Bahama. And about the same time, there were some Hurricane Hunter flights flying into the center of the storm, and the picture on the top right here is essentially Dorian from inside the eye taken from the Hurricane Hunter aircraft. So as you would expect, a storm of this nature staying in place for several days created catastrophic damage on Grand Bahama and Great Abaco Islands. 13,000 homes were destroyed, about 70 fatalities there, $3.4 billion US in damage, and recovery continues to this day and will continue for several years to come. And based on some of the calls that I've been on the last few weeks, hurricane recovery in the midst of a pandemic is really, really challenging in the Bahamas right now. So once we got into early in the week, which was just after Labor Day weekend, it started to be clear that there wouldn't be a landfall in Florida, and it was kind of heading on to the Carolinas and then potentially up into Atlantic Canada. So despite the storm not making landfall in Florida, it still created some damage there because of the close proximity of the storm as a major hurricane. So they did nonetheless get a fair bit of damage there because of Dorian. So throughout this period, we are continuing to talk to our emergency managers on this. So by the 4th of September, that turn towards the north had started, and it was clear that Florida would not receive a direct landfall. But the question for us here in Canada is whether it would make landfall in the Carolinas, because that made a big difference for us if we had a storm that exits the Carolinas after making landfall, in which case we would be dealing with a much weaker storm, or a storm that just grazed the coast or stayed just offshore. In that case, we would be dealing with a much more serious storm, and it's the latter that ended up happening for us. So on that September 4th, we started issuing our bulletins every 6 hours, updating people on the storm. As it was going through, as it approached the Carolinas, they were getting ready. It actually did make landfall on the Outer Banks on the morning of the 6th. That was the Friday morning. There were power outages, flooding reported there, a lot of damage as a result of tornadoes in the Carolinas with Dorian. They had 3 fatalities, specifically in North Carolina. Many of those, I believe, were drownings as people were still trying to drive into flooded waters. There's $1.2 billion in damage in the U.S. And as this storm, as Dorian was going over the Outer Banks, you can see the analysis of the storm here on the upper right map here. We have 2 wind barbs that are actually pointed in opposite directions, which is a perfect indication that this particular storm was going right between those 2 weather stations, because, as I say, one station is reporting wind from one direction and the other is reporting strong winds from the other direction. So it means that the center is right in the middle of those 2 stations. So it gave us a really good location on the storm as it was exiting the Carolinas and headed towards Atlantic Canada. So again, on that Friday, the 6th, we continued to issue our bulletins every 6 hours. We had been issuing bulletins for about 2 days up to that point, and all our computer models showed a very powerful storm reaching the Atlantic coast of Nova Scotia sometime on that Saturday, probably later in the day on Saturday. We had hurricane watches that were up that morning that were eventually upgraded to warnings later in the day. And we were pretty much joined at the hip with our emergency managers at that point. And we also had a media briefing for the approach of Dorian in the afternoon of September 6th. So after impacting the Carolinas, the storm raced towards Nova Scotia, so it started to accelerate as we would expect from what I was discussing earlier about what happens to these storms when they move into northern latitudes. And so that extratropical transition actually began in the few hours after reaching the Carolinas, and it was actually declared post-tropical, which doesn't mean it's a lesser storm. It just means that the structure is different than a pure tropical storm. So it was declared post-tropical by the National Hurricane Center at 6 p.m. Atlantic time. And about an hour and 15 minutes later, it made landfall just southwest of Halifax. From there, it crossed Nova Scotia into the Gulf of St. Lawrence and impacted Prince Edward Island, New Brunswick, and eastern parts of Quebec and Newfoundland, especially western Newfoundland as well, where they experienced some power outages there. So looking at the wind impacts, we had a large area of winds of 100 kilometers per hour or more, with peak official wind was 145 kilometers per hour. We did get a report, still looking into that report, from a sailboat on the South Shore that reported a peak gust of 161 kilometers per hour. You see some of the damages from the wind, of course, the infamous crane that collapsed in downtown Halifax, which we were very lucky that nobody was injured or worse with that particular mishap. And a lot of the damage that we saw was similar to what we saw with Juan, Hurricane Juan, back in 2003. So rain impacts, again, we did get substantial amounts of rain with Dorian, a large swath of over 100 millimeters with a peak rainfall of 190 millimeters, again, along the South Shore of Nova Scotia. Significant flooding, especially in Nova Scotia and southeastern New Brunswick as a result of the rainfall. We also saw significant storm surge, both on the Atlantic coast and Northumberland Strait. So the graph that you see on the right here is actually the tide gauge at Shediac, New Brunswick, just about 20 minutes away from the Moncton area, right on the coast, which actually recorded a storm surge of 2 meters in the Northumberland Strait. So there was significant damage there to the marina and some other areas along the coast of the Northumberland Strait in Nova Scotia and New Brunswick. Also some damage along the Atlantic coast as well as a result of the storm surge. So moving on with the rest of the hurricane season, later on we did have Ferdinand. That was a weak tropical storm that formed in the Gulf of Mexico. Gabrielle was a tropical storm that stayed over the Atlantic with no major impacts there. And Humberto, which ended up being our next major hurricane, we actually kind of dodged a bullet with that particular storm. If you look at the track that's on the upper right here, you can see that it made a fairly sharp turn towards the east, almost 90 degrees, and then became a major hurricane within the next couple of days after that. And you can see the satellite image on the bottom right, and that storm is actually pushing clouds back onto the southeastern part of the U.S. So that area, that storm, if some of the other steering currents weren't in place, could have made landfall as well as another major hurricane. Tropical storm Imelda, which was another high impact storm, even though it didn't reach hurricane status, it produced over 1,000 millimeters of rain along some areas of the Gulf Coast, which again caused tremendous flooding in that area, an area that was severely impacted by rain with Harvey a few years ago as well. So that same area got impacted again. Then we had Hurricane Jerry and then Tropical Storm Karen. Again, no major impacts reported from those storms. And then we had Lorenzo. Lorenzo was another interesting storm in that first of all, it became a major hurricane. It formed on the 23rd of September and then became a major hurricane on the 26th. And it set a record for the strongest storm to become a Category 5 that far east. Usually it takes more time for a storm to reach that intensity as it's moving across the Atlantic. So it became a Category 5 storm that formed a lot further east than any other storm had before. So for the most part, it stayed over the ocean, but it was still a high impact storm as it contributed to the sinking of a tugboat that was actually in that area, unfortunately, and there were 11 fatalities in that particular sinking. And interestingly enough, there were 8 fatalities along the east coast of the U.S. just because of the waves and rip currents from Lorenzo. And you can see the wind swath from Lorenzo a long ways away from North America, yet it still generated enough wave action to result in 8 fatalities along the east coast of the U.S. Then we had Tropical Storm Melissa that formed on October 11th, caused some minor coastal damage in the U.S. Nestor was another storm that formed in the Gulf of Mexico and created some flooding in that area. Then towards the latter part of the season, we had Tropical Storm Olga that formed on October 25th along in the Gulf of Mexico. And that storm became a fairly significant wind event all up the Mississippi Valley as the storm actually moved into, made its way up to Michigan. So there were significant wind damage with that particular storm late in the season. Then we had Pablo that formed on October 25th and became the last hurricane of 2019. It stayed over eastern parts of the Atlantic, so there are no reports of damages or casualties. Then the last 2 tropical storms of the season, Rebecca and Sebastian, that again stayed over the open ocean, and there were no reported damage or casualties with either of those 2 storms. So if you look at overall last season, it was tied for the 4th most active season. 7 out of the 18 storms that formed in 2019 didn't last very long, only 24 hours or less, the most on record. The previous record was 6. 2019 was the 5th consecutive year that we had a storm form before June 1st, and actually this year is the 6th consecutive year, and that is a record. Dorian reached Category 5, and that made it the 4th consecutive year that the Atlantic has seen a Category 5 hurricane. Of course, last year we had 2 of them with Dorian and Lorenzo. And again, as I mentioned earlier, Lorenzo was the farthest east that an Atlantic Category 5 hurricane had ever formed on record. So a few tidbits about last hurricane season. So with that behind us now, we look ahead at what we might expect for this hurricane season, which is already kind of shown to be a fairly busy one. I'm just going to focus on 2 of the main factors that we look at. One, of course, is the water temperature, because remember, water temperature, warm water is essentially the fuel that drives these storms. And wind shear in the Atlantic, because that is a predictable thing that we know has an impact on the number of storms that we get over the course of the season. So we look at water temperature. This is a map depicting the departure from normal of sea surface temperatures in the Atlantic. And this was as of Saturday. And you can see a large part of the tropical Atlantic is anywhere from a ½ degree to 1.5 degrees warmer than the average for this time of the year. And we know that the ocean temperatures are just going to keep getting warmer over the course of the summer. So we're already ahead of the game in terms of water temperature in the area where these storms develop. So that's a big factor driving what we expect for this season. The other thing is whether or not we expect a lot of wind shear in the atmosphere in the tropics where these things form. Because when we have an environment that has a lot of wind shear, or in other words, the winds change significantly with height, either in direction or speed or both, whenever we have that, the storm can never really get going. It literally gets sheared apart. So one of the things that we know drives wind shear in the tropical Atlantic is whether or not we have an El Niño happening or not. So right now, an El Niño essentially is an area of warm water in this larger rectangle here that you see in the Pacific. So when we have warmer than average temperatures in that area, we have an El Niño. Right now, it's kind of a combination of cold and warm. So overall, what we're in right now is a neutral condition. So it's neither El Nino, where the waters are warmer in that rectangle, or a La Niña, which is the opposite, is where the water temperatures are colder. However, that also gets predicted in the coming months. So if we look at what those predictions are for whether or not we're going to have an El Nino, and this is, excuse me, the main time frame that you see here, ASO, essentially stands for that 3-month period of August, September, and October. So if we look at those predictions, there's just over a 50% chance that we're going to stay in a neutral condition as far as El Nino is concerned. And there's also a close to 40% chance that we will actually have a La Nina situation, not only a 10% chance that we'll see an El Nino. So there's an overwhelming probability that we won't see a tremendous amount of wind shear in the atmosphere in the Atlantic this year. So with warmer temperatures and lower wind shear, we do predict an active season. And this is the outlook that NOAA issued just last week. They usually issue their outlook towards the end of May, and again, they updated in August, but these are the numbers that were issued by NOAA towards the end of May. And the numbers are 13 to 19 named storms, where the average is 12. Of those storms, 6 to 8 would actually become hurricanes, where the average is 6. And of those 6 to 10 hurricanes, 3 to 6 would actually make it to major hurricane status, and the average is 2 to 3, around 2.7 is the average there. So certainly looking like an active hurricane season this year in the Atlantic. And we're already headed in that direction because we've already had 2 storms named so far. And then there's another area that has a medium chance of becoming a tropical storm here within the next 5 days or so. So there's already activity in the Atlantic as we speak. So what does this mean for Canada? Well, this is a graph that we've been keeping track of over basically the whole existence of the Canadian Hurricane Center, and I update this every year. Basically, on average, there's about a 30 to 40% chance, or 30 to 40% of all the storms that form in the Atlantic end up making it into our Canadian Hurricane Center response zone. That doesn't mean they all have an impact on land or even over our marine territory, but they find their way into our Canadian Hurricane Center response zone. One thing that I find is interesting is 2010, 2011, and 2012, all those 3 years, there were 19 named storms, which is the top end of the predictions for this year. In 2010, we only had 3 that entered our response zone, whereas we had 7 in 2011 and 5 in 2012. So fairly variable in terms of how many storms we get in our response zone. But a footnote to that is that 2010 season, we actually had 2 landfalling hurricanes in Canada, even though we only had 3 storms entering our response zone. 2 of those were landfalling hurricanes, with Earl here in Nova Scotia and Igor in Newfoundland and Labrador. So the moral of the story here is that you basically have to prepare the same way for a hurricane season, regardless of what the predictions are for the overall activity in the basin. So just finish up here with a couple of websites that you can use. This first one here is for the National Hurricane Center in Miami. They have a variety of different products that will provide information on the probability of formation of storms. Once a storm actually does form, where it will go, some of the uncertainties, the key messages for a particular storm, wind probability maps, the projected time of arrival of certain wind speeds. So there's a lot of information on this website with our partners down in the US. Once a storm is expected to approach Canada, then we activate the Canadian Hurricane Center to provide updates every 6 hours as well. So you use this in conjunction with the information coming from the National Hurricane Center. If you want more details on what might happen in Canada, we talk a lot about impacts of what we expect as a storm is approaching. So that's our website, hurricanes.ca. We also have a fairly new weather app that can be downloaded on the Apple App Store or Google Play. And we have our Twitter accounts that we just activated last summer to monitor, that we send out information on these storms. And there may be some information on some of these Twitter accounts that we will have in our bulletins as well, and even some that some of the information may not be in the bulletins. So if we want to get something out quickly, Twitter is a very good tool for us to do that. So with that, I'll conclude the presentation, and for 2020, thank you very much.